After discussing electrolysis of sulfuric 6 acid, I want us to talk about the quantitative treatment of electrolysis, also known as the calculations of electrolysis. Quantitative treatment of electrolysis. What quantity? That will help us to answer questions like what quantity of electricity is required to deposit 1 mole of atoms of lead. That is from electrolysis of molten lead 2 bromide. And it is this that will help to know the mass deposited, the charge of a given element, and so forth. So to start, I want us to recall the chemistry of current. The total charge carried by the flowing current is measured in coulombs. C. The total charge is also referred to as quantity of electricity. A current of 1 amperes flowing for 1 second carries a quantity of 1 coulomb. So that is to say, Q is equals to IT. Where Q is the quantity of electricity in coulombs, I is the current, and T is the time in seconds. Example: a current of 2.5 amperes flowing for 15 minutes carries a quantity of electricity of, so that will be Q is equals to IT, that is 2.5 times 15 times 60, because time has to be in seconds. So that is 2.5 times 15 times 60, giving a quantity of 2,250 coulombs. Faraday's first law. States that The quantity of a substance discharged or dissolved at the electrodes during electrolysis is directly proportional to the quantity of electricity that has flowed into the circuit. States that the quantity of a substance discharged or dissolved at the electrodes during electrolysis is directly proportional to the quantity of electricity that has flowed in the circuit. The following reaction takes place in the electrolysis of molten lead to chloride. The reaction is sodium ion plus electron to give sodium solid. The sodium ion needs one electron to form sodium atom. Likewise, 1 mole of sodium ion will need 1 mole of electron for reduction to sodium solid. It can be shown that 1 mole of electron carry a total charge of 96,500 coulombs. This is also called Faraday's constant, and it is true that 1 Faraday is equals to 96,500 coulombs, and that is the constant. So when you talk about 3 moles of electrons, then it is 3 times that. The quantity of electricity for 3 moles will be 3 times that 96,500. If you talk about 2 moles of electrons, then the quantity of electricity to lose the 2 moles or gain the 2 moles will be 2 times 96,500 coulombs. Examples. Number 1, find the number of coulombs. First, when a current of 5 amperes flows for 3.5 hours. Solution: Q is equals to IT, that is 7/2 times 3600 to convert into seconds times the 5 amperes. This is 1800. So we have 35 times 1800, 1800. That gives 63,000 coulombs. That is the quantity of electricity. Example 2. Calculate the mass of lead discharged at the cathode if 1 Faraday is passed through molten lead 2 bromide. Solution: first of all, we want to write the equation at the cathode, that is lead ion plus 2 electrons leading to lead solid. That is 2 electrons, so it means 2 Faraday will give a mass of lead. Pb is 207 as a provision. So therefore 1 Faraday would require a mass of 207 divided by 2, and that is 103.5 grams. We can use formula method to get the mass deposited. So in the formula method, mass deposited, mass that is deposited is equals to RAM times Q, the quantity of electricity, over 1 Faraday times moles of electrons. So that would be RAM 207, quantity is 1, and that is 1 Faraday as well, times moles of electrons are 2, and that gives 103.5 grams. Our next question, example 3. copper 2 sulfate solution is electrolyzed using inert electrodes. A current of 5 amperes was passed for 45 minutes. How much copper was deposited at the cathode? So again, we want to use the two methods to calculate the mass that was deposited. So now we have first to calculate what is known as quantity of electricity is IT, which is 5 times 45 times 60, because time has to be in seconds. That is 5 by 45 by 60 gives 13,500 coulombs. Moles of electrons. So we have very clear that 96,500 coulombs gives 1 mole of electron. What about 13,500? That would give 13,500 divided by 96,500. 96,500. That is resulting to 0.1399 moles of electrons. Now, equation at the cathode equation will be copper 2 iron plus 2 electrons giving copper solid. So we have 2 moles of electrons with a mass of 63.5 grams of copper. What of the so-called calculated moles, that is 0.1399 moles. What will be that? That is 0.1399 times 63.5 all over 2 moles times 63.5 divided by 2. That is 4.442 grams as the mass deposited. Let's use the formula method. Alternatively, we'll have mass deposited is equals to quantity times RAM over 1 Faraday times moles of electrons. The quantity is calculated as 13,500. What you do in the first step, you just take the calculation for quantity 5 by 45 by 60 times RM 63.5 all over 1 Faraday, that is 96,500 times moles of electrons. From the equation we have 2 moles, so that would give 5 times 45 times 60 times 63.5 divide by 96,500 times 2, cross the bracket, that gives 4.442 grams. That is another formula that you can use to calculate the mass deposited. Last example, that is example 3 or 4 for that matter. We have 3 amperes, 3 amperes were passed through an aqueous solution of nickel for 6 hours. (19.8 grams of nickel metal was obtained. Find the charge of the nickel ion. Solution. The equation of the reaction plus N electrons will give nickel solid. After that, we calculate quantity. Q is IT, that is 3 amperes times 6 times 60 times 60. Then the quantity there is 64,800 coulombs. Now N by 96,500 gives 59 grams of nickel. Remember, that is the RAM of nickel. 64,800 gives 19.8 grams of nickel. Find the value of N. So now we can multiply and get N. So that implies that N times 96,500 all over 64,800 is equals to 59 all over 19.8. So that multiplication will give N is equals to cross multiplication 59 times 64,800 all over 19.8 times 96,500. So that would give N to be 59 times 64,800 divided by 19.8 times 96,500. That is approximately 2. So the charge in the nickel is 2, because that is N is 2. So alternatively, we can use the formula way that states that charge is equals to RAM times quantity of electricity over mass deposited multiplied by 1 Faraday. So that is 59 times 64, or we can multiply direct, that is 3 times 6 times 3,600, because we have to convert into seconds. So that is 59 times 3 times 6 times 3,600 over the mass deposited 19.8 times the Faraday constant, that. And that calculation gives 2. Therefore nickel is of that charge. So that is all about the quantitative treatment of electrolysis.